Hi there, today we're going to look at the structure of the atom. I've got a real simple diagram of the atom here. We're just going to start off by labeling it. This is a simple Bohr model. We've got two shells here, and we have a nice nucleus here. And then in the nucleus we've got these ones that I've coloured grey. They are neutrons. We've got these ones that I've coloured red. They are protons. And in the shells we've got these ones that I've coloured blue. They are electrons. Now we need to remember the masses of the subatomic particles, or at least their relative masses in A-level chemistry, and their relative charges. So if we just quickly do a table, can we remember what the mass and the charge is? Just have a think for a second. Good, yeah, the mass of the neutrons is 1, mass of protons is 1, electrons is 0, charge of neutrons is 0, protons is +1, and electrons is -1. You may have a different number to 0 here for the electrons. You could have 1 over 1,800, 1 over 2,000, they would also be accepted, but we're keeping it simple. Now in the case of this atom, I've got 3 protons, I've got 4 neutrons, and so in this case we should be able to identify which element this is and which isotope of this element it is. So if it's got 3 protons, that means it's got an atomic number of 3, and so that means it must be lithium. And if it's got 4 neutrons, then 3 plus 4 is 7, so it must be lithium 7. It is an isotope of lithium, lithium 7. Isotopes, remember, have the same number of protons, different numbers of neutrons. They have the same chemical properties because they've got the same electron configuration, but they are slightly heavier or lighter than each other. Okay, I'm going to pause for a second. You're going to have a go at these questions just to make sure everything's got stuck in. Okay, when you're finished, unpause them and I'll show you the answers. Good luck. Okay, so you should have answered these questions by now. Here's the answers. Double check you've got them right. I'll just make them a little bit bigger so they fit on the page. There we go. I'll pause again. Make sure you've got them right. Unpause when you're ready. So now what we've got here is we've got some activities here designed to check that you can accurately work out the number of protons, neutrons, electrons of a given element. Use your periodic table to work out the numbers of protons, neutrons, electrons in each of these. Please pay close attention to the ones that are ions. Please, I've just highlighted here. Okay, unpause when you're ready and we'll check you've got them right. Good luck. Okay, let's see how you did. Here's the answers for them. Double check you're right. Again, pause a sec, mark it, and move on. So the real basics. I expect most people are feeling fairly confident with all that. We've got our isotopes. We've got our nucleus. But what about if we need to calculate the relative atomic mass? Now, the relative atomic mass of a substance is defined as the mass of one atom relative or divided by the mass of 1/12 of carbon 12. Now, we can also change that definition slightly if we want to. We could say it's the mass of 1 mole divided by the mass of 1/12 a mole of carbon 12. We could say it's the mass of one atom or the mass of 1 mole. As long as we have it the same above and below, it's completely fine. So that's our relative atomic mass. How do we actually calculate that in reality? Well, let's say we've got an example here. Let's think of bromine, Br2. Now bromine exists in two different isotopes. One is called bromine 79, one is called bromine 81. And how they exist in nature is essentially 50-50. Okay, they're actually 49-51, but we're just saying they're 50-50 to make life easy for ourselves. 50% here, 50% here. So I take a random sample of bromine. I'd expect 50% of the atoms to be the 79 isotope, 50% of the atoms to be the 81 isotope. So how do I work out the relative atomic mass? Well, I could just add one of these and one of these and then divide by 2. I could take an average because these are in a 1-to-1 ratio. But that doesn't help me solve, I'm just going to write this 50% here. It doesn't help me solve the problem of unusual examples. So this is the foolproof way of doing it. What we're going to do is we're going to do a weighted average. Okay, so a relative atomic mass of bromine is going to be the percentage 50 times by the mass 79 added to the percentage 50 times by 81, and then both of those are going to be divided by the total of these two numbers, which in this case is 100 because we're dealing with percentages. So if I add up these number times by this number times by this number, and I'm dividing by whatever the percentages are, and in this case I would obviously get 80.0 grams per mole as my standard relative atomic mass in this example. But it's a weighted average, and the reason this way is preferred is because sometimes you're not given a percentage, sometimes you're given a mass. Okay, so sometimes, let's say we had a different example here. I'll change color, give myself a little bit more space. Let's say we're still using bromine as our example, 79, bromine 81, but in this case I got 2.4 grams of this and I got 2.6 grams of this as an example. So when I do this problem, I'll need to go 2.4 times by 79 plus 2.6 times by 81, and then I'm dividing by these two numbers added together, which is 5.0. So the reason this method is preferred is because it works for all situations. And if you can ever have an example that works for all situations, then it's always the best method to use. We could do other things with the percentages, like turn them into decimals and things like that, but sometimes these quick routes aren't actually the most effective ways of doing it. So that's how we calculate the relative atomic mass. What I've got here is a few questions for you to help you think about those ideas. Pause it, answer the questions, and then I'll show you the answers in a second. And here's the answers. Pause the video for a second, mark your answers, make sure you've shown your workings for everything, and remember, it's really important that we know that isotopes have the same chemical properties, okay, because they're the same electron configuration. So from this video, we've revised the structure of the atom a little bit, and we've revised how to work out the relative atomic mass using a weighted average approach. Okay, hopefully you found that helpful. If you have, please like and subscribe to the channel, because I'll be putting up more content as the year goes on. All the best. Take care.